Okay, guys, so what we have so far, what we have seen here is we've seen that the slope or the rate of change for the table is constant, right? 1 over 5 as you go down. No matter what, it's 1 over 5, right? We see a constant slope. However, in the second table, we have calculated our slope and we determined that the slope is increasing as you go down. So this is not a constant slope, right? This tells me that the first table represents a linear function because your slope is constant, while the second one does not represent a linear. So the slope is constant.
There is some technical word for not linear.
It is non-linear. This is what it is, but in this case, you're going to see that it's actually exponential. But let's look at this. Right? This is the graph of the first table, right here, and we can see that this graph is a linear function, right? It represents a linear function, and we can tell that the rate of change is constant. And all points are on a straight line. For the second one, the rate of change is increasing. Every 10 kilometers per hour.
It's like, dude, it's like flash.
Interval. And the points are not on a straight line.
You're gonna make
Okay, so for the next question, So the table below shows the change in height of a tomato plant from germination until tomato ripe. So there is a table and there is the graph as well. So this is the time per weeks on the x-axis and the height of the plant on the y-axis. So the question is asking you to determine when the rate of change in the height is 0, when the rate of change in the height is constant, and when the rate of change is changed. So because it's asking for the rate of change, what do you have to calculate? The slope. Okay, so what we've been doing? Slope, y2 minus y1 over x2 minus x1. So if I do the slope here, it will be 5 minus 0 over 2 minus 0. So 5 over 2, which is 2 points. And if I do this, 10 minus 5, that's 5. Over 4 minus 2 is 2. So that will be again 2.5. So far what have we seen between the first week, first 2 weeks, and then the first 4, then the next 2 weeks? They're the same, right? And if we do 20 minus 10, that's 10, divided by 2, that is 5. So we see that between week 4 and week 6, we have a rapid increase, right? Almost double. Double, actually. If I do 40 minus 20 over 8 minus 6, so that's 20 over 2, that's 10. So we also see that between week 6 and week 8, we have an even higher increase. I want to show you this. So can you guys look for a second? So the first rate of change, 2.5, is this. Second rate of change, 2.5, is this. You see that the rate of change, so the way that the line is going up is similar, right? Then between the rate of change between week 4 and 6, we see a double. So it's the same 2 weeks, but it's increasing a whole box, right? It went up the whole box. Between 6 and 8, it went up 2 boxes high versus 1 box right. Okay, we see that? So this is basically what represented by 10. Now, next one, what's 75? So we have 75 minus, did we do 58 minus 40? No, we didn't. So that's 18 over 2. So that is 9. What are we starting to see? A decrease in this. 17 over 2. So 17 over 2. 8.5. 11 over 2. So, for the first, so between 4 and 6 it's increasing fast, between 6 and 8 it's increasing the fastest. Then if you go between 8 and 10, it's still increasing fast, but it's slower than before. Between 10 and 12, it's increasing fast, but again, less than before. Then it's starting to go less faster, right? Less faster, slower, right? Until it reaches a point where it's not going to change anymore. So between 16 and 18, there's no change in the height of the plant. So when did the plant change the most? Between what weeks?
8 and 10. 6 and 10.
6 and 8. 6 and 8. That's when they had a slope of 10. Okay, so that's when it grew the fastest, right? And then between 8 and 10 is when they grew the second fastest, right? Now, when was the rate of change 0? Determine when the rate of change in the height is 0. Okay, between weeks 19 and from 16 to 18, you mean, right? From 16 to 18, right? If I do the difference between these two, if I do the slope right here, I'm gonna get a slope of 0. When was the slope constant? Slope is
18,
constant.
18.
Oh, okay, yeah.
The slope is constant between 0 to 4, right? That's when the slope is constant.
Maybe it wasn't starting the whole
Well, 0 to 2 was 2.5, 2 to 4 was 2.5,
Need that.
right? So constant between this and this. And it's changing between 6
to
6
18.
to 8, 6, 4
4
to 16.
You go.
From 4. Right? From 4 to 16. So we discussed this. When is the rate of change in height the greatest? When did we see the greatest change in height? Between what week and week?
6 and
Between week 6 and 8. Yep. So from week 6. So I'm gonna write this sentence. So it grows at a constant rate. Grows at a constant rate. We already discussed all this from 0 to 4 weeks. Then grow and the growth rate increases for the next 4 weeks. Then the growth rate decreases as a plant reach maturity. After week 16, the plant stop growth.
Yeah, it's important. You try to one spoonful is dead.
you to look at this for a second so I can turn off the podcast. So if your first difference is 0, right, or rate of change is 0, then your graph is gonna look constant. It's gonna look like it's a straight horizontal line, right? And we have seen that right here. So it's gonna plateau. We call this a plateau, okay? So this way your slope is 0. There's no increase at all. If your first difference or if your rate of change is constant, right, then you have a linear growth, okay? If your rate of change is changing, like we have seen in the middle right here, if the rate of change is changing, right, you'll see kind of a curvy graph, okay? So if it's constant, you'll see a linear graph. If it's curvy, if it's changing, you see a curvy graph, okay? So copy this, and then you guys can start your homework. Let me save this first before I turn off my podcast.